Okay, we're going to talk about lines in this video, something that hopefully you're pretty familiar with at this point in time. There are three different forms that you can use to write an equation of a line. The most common is slope-intercept form. That's the one I'm going to use the most, but I do want you to know that these other two are things that you can also use. So there's point-slope form, where if you have an xy point on your line, and that would be x1, y1, and then you have the slope, you could do that. And then there's also standard form, which you will see from time to time, but standard form is typically we're going to want to rewrite that into slope-intercept form so that we can graph it. Remember, with slope-intercept form, m is your slope and b is your y-intercept. First example I have here deals with a word problem where I'm going to use slope-intercept form. So we have a truck rental company that charges a flat rate of $50 plus an additional 10 cents per mile. How much would it cost you to go 100 miles? So that's the first question. Well, I'd want to come up with an equation here. So a pretty common setup for this is going to be, like I said, slope-intercept form where a rate is involved. So it's 10 cents per mile. So I know that my slope is going to be 10 cents, 0.10. But then they also charge a flat rate. So that flat rate is your y-intercept. So we have a slope of 0.10 and a flat rate of $50. That's my equation. How much would it cost you to go 100 miles? So if I want to answer that question, I'm simply going to plug in 100 in for x. And then I'm going to work this out. So 0.10 times 100 is going to be 10 plus 50. That's going to be $60 is how much it would cost. $60 to go 100 miles. Is this company a reasonable option for you if you need to go 250 miles but your budget is $70? So what we could do here is say, well, we want to only spend $70, which is what y is representing in this. This is how much we're actually spending. And I want to know, does that equal, or is that less than or equal to? Really, I could make this an inequality. Does that equal, or is it less than or equal to this 0.10 times 250 plus 50? Now you could just really work out the right side here. So 10% of 250 is 25. 25 plus 50 is 75. And unfortunately, because this number is bigger than 70, I'm outside of my budget, and therefore the answer to this would be no. That is not a reasonable option for us unless we want to go $5 over our budget. A line goes through the point 26 with a slope of -3. Write the equation of this line and determine the x and y intercepts. So if I want to write the equation of this line, if I just start with slope-intercept form, I'm going to use this as my x and y in that. So what I need to do is find b. I've got the slope, so I have y equals -3x plus b. I don't know what b is, but I do have a point where I can figure that out. So my 0.26, I'm going to plug that in for x and y. And so I would get 6 equals -6 plus b, so b is going to be 12. And therefore my equation is y equals -3x plus 12. That answers the first part. And then also determine the x and y intercepts. Well, the y-intercept is easy. The y-intercept is simply, what is my b? So that's 12. And sorry, you should probably write this as a coordinate point. So the y-intercept is 0, 12. The x-intercept is going to take just a little bit of work. The x-intercept, to figure that out, that happens when y is 0. So to figure out the x-intercept, I'm going to plug in 0 for y, and I'm going to solve this. So 0 equals -3x plus 12. If you subtract the 12 over, we would get that -3x is equal to -12, and therefore x would be 4. So my x-intercept is 4. So you could say that as a point, that's 4 comma 0, right? My x is 4 when my y is 0. So if you write the equation of slope-intercept form, you've got your y-intercept really quickly. Just a little bit of work to find your x-intercept there. All right, given the equation below, find two lines, one that is parallel, the other perpendicular, that each go through the point 1, 3. So to find the one that is parallel, you should hopefully know or be able to figure out that parallel lines have slopes that are the same, right? Because they're never going to cross. So I know that my line that I'm going to write that's going to be parallel to this also needs to have a slope of 2. But then it has to go through this point 1, 3. So again, I could do this in point-slope form. I could do this in slope-intercept form. Let me show you point-slope and why it might be a good option to use here if you forget how that works. Point-slope form, simply just need to put y minus the y-coordinate of my point equals the slope times x minus the x-coordinate of my point. And I'm done because it just says find two lines, and that's a line. It's just written in point-slope form. So that's the easy route. You could do a little bit of extra work to get the slope-intercept form to that by converting or starting with slope-intercept like I did up here. So I could always start with this and just solve for b, or I could write it as point-slope form, distribute my 2, add the 3 over, and then I would have slope-intercept. So if I did that, if I distributed the 2, I would get 2x minus 2, and then if I add the 3, that would be plus 1. So either one of these is fine, however you want to write that. It's the same thing. And then for perpendicular, the only thing you have to change here is that your slope is not 2. Your slope is opposite and reciprocal of that. So your slope is going to be negative 1/2. And the point is going to be, again, still going through 1, 3. And so we have y minus 3 equals negative 1/2 times x minus 1. So that's one way I could write it. That's perfectly fine. If I wanted to use slope-intercept form, I would distribute the negative 1/2. So I would have negative 1/2 x. And then I would do negative 1/2 times negative 1 would be positive 1/2, but then I would have to add my 3 over to that, so positive 1/2 plus 3 would be 3.5, but I'm going to write that as as an improper fraction and not a mixed number, so 3.5 is going to be 7/2. And that is my equation that's perpendicular. So if you were to graph those two lines, you would see definitely parallel to 2x minus 10. Go ahead and do that. Y equals 2x minus 10. So we see that. Zoom out just a little bit so you can see the y-intercept there. I'm also going to do y equals 2x minus 1, and you should be able to see that it is 2x, oh sorry, it's 2x plus 1. So 2x plus 1, it is parallel to that. And does it go through the point 1, 3? Yes, it does. That's right here at 1, 3. And then we also have y equals negative 1/2 x plus 7/2. And again, you see that that is perpendicular to these lines, but also goes through the point 1, 3.